Welcome to Who's in STEM. I'm Ken Ono, your host and the STEM advisor to the Provost and the Marvin Rosenblum Professor of Mathematics at UVA. Our goal is to evoke flights of imagination and wonder by showcasing the cornucopia of all that is STEM at UVA, the marvelous world of UVA science, technology, engineering, and mathematics. People picture scientists plugging away all day in boring, sterile labs, totally separate from the outside world. But communication is incredibly important to the practice of science. In addition to experiments and digging through the data, scientists must be able to tell the public why the research matters. That's why we, at the Provost's office, want to collaborate with this excellent podcast. It's called the Story Collider. The goal at Story Collider is to reveal the vibrant role that science plays in all of our lives through the art of storytelling. And in April, the Story Collider team came to UVA. They came to Charlottesville to record a few of our STEM leaders who told stories about their careers and their research. I hope you'll head over to their feed to hear a story from UVA neuroscientist Sara Kucenas. And then on July 21st, Story Collider will share a story told by my good friend and math professor, Sara Maloni. But first, we have a few more stories that were recorded at the live Story Collider event. First up, UVA Professor of Environmental Change, Scott Doney.
So the question I had been dreading all day finally came. It was, Scott, tell me something interesting about your science. Something that somebody in the general public is going to find gripping and exciting and intriguing. And my response was, well, what do you know about helium isotopes in the ocean? And the trainer kind of gave me one of those head shakes like, do you even know why we're here? So to give you a little bit of context, so this was 2004. I was at a science communication workshop. It was wonderful. I had gotten a fellowship. It was this week-long program with working journalists and trainers and other environmental scientists, and it was this great opportunity, and I had nothing. I had my helium isotopes. I think helium isotopes are really fascinating, and helium's a noble gas, and so once something generates a signal in the ocean, it doesn't get affected by all the messy chemistry and biology that goes on in seawater. And so if you can actually measure it, it's really hard. You have to take very careful measurements. I have friends with really expensive mass spectrometers. But if you can do that and work through all these messy details, you can actually learn something really interesting in the ocean. And I had come to this workshop with this storyline about how we were measuring helium in the deep North Atlantic, and this was helium produced by radioactive decay of tritium that was released during the weapons testing in the 1950s and 60s. And it was this unique signal of how quickly water gets from the deep ocean back to the surface. But that's a really hard sell when you're trying to talk to a journalist. And for context, other environmental scientists at this workshop were talking about works saving spotted owls and old-growth forests in the Pacific Northwest. One scientist was working on stopping illegal deforestation in Indonesia. Another was cleaning up toxic waste dumps around Chicago. And I had my helium isotopes. So I did know that this was going to be a problem, and so I had come with a backup plan. About a month earlier, I had bumped into a colleague who had just come back from this exciting meeting in Paris. And she was so excited. She was talking about this problem of ocean acidification, which the name was only maybe a year or two old. Nobody had really written much about it. But it was like, oh, this is really cool. I could maybe think about talking about this. And so I decided to use that for the rest of the week-long communication workshop. So the basics, acidification. We have our energy and our transportation systems built on fossil fuels. They're hydrocarbons, you burn them. The carbon in the hydrocarbons turns into carbon dioxide. Some of that gets into the ocean, where the carbon dioxide makes weak acid, changes the seawater chemistry, and might affect marine life. So that part's pretty straightforward. It's been known for a long time. What people didn't know was, is this going to affect marine life? So things like corals and shellfish and plankton. Lots of things build shells and skeletons out of calcium carbonate. If anybody's taken a basic geology class, the way you tell something's limestone is you squirt a little carbonic acid on it. That's basically the experiment, but now on a global scale. So I was all set. I came back to the workshop. I had done some homework ahead of time. I had emailed some colleagues and said, tell me about some of the experiments you're doing. And then I used that for the rest of the week. So there were mock radio and TV interviews. I wrote op-ed pieces. And one of the final things we did on the last day was we wrote a pitch for Scientific American, which is a popular science magazine. About a year later, I get this email from the same editor who'd been a trainer at this workshop. And she wanted to know if I'd actually write an article for real, for Scientific American. And I was like, oh, this is really, really cool. You know, I'll get to use the skills that I got from this communication workshop. And for me, also Scientific American, the articles are written by practicing scientists. And for me, that was sort of my first exposure to real science, not, you know, sort of classroom stuff, lecture material, but this was pretty cutting edge stuff. And so I'd been reading it through high school and was like, wow, this is this great opportunity. So I went ahead and wrote the article. It came out in 2006 to a bit of a splash. It even got translated into German, so I had to dig up my high school German and try to check, let's see. But it got republished in the German version of Scientific American. And so this was fantastic. You know, I'd finally done something from the science communication workshop. But what I didn't even understand at the time was this was going to change my career. Because once that got out there, I started to get asked to come talk to people, talk to local political leaders, congressional staffers. I remember one time I did an event at the aquarium in New Bedford, Massachusetts. And there were city leaders, there were people from the federal government, but there were also fishermen. New Bedford's a huge fishing port, and a lot of them fish sea scallops, which is one of the more valuable fisheries in the entire United States. And they're looking at me and they're saying, quite befuddled, they're saying, somebody is burning coal somewhere in the world, and this invisible gas is gonna float down into the ocean, and it's gonna destroy my livelihood. It's gonna destroy this fishery that my family has been fishing for decades. And I was like, well, we don't know yet, but maybe. And so this led to me having to change the way I do my science. Because one of the things engaging with stakeholders that I figured out was all the things that I'm used to answering are not the questions that they want to know answers to. They didn't want to know about the details of the chemistry or, you know, how many replicates were done in a biological experiment. They wanted to know tough answers to really tough questions like, is my fishery going to disappear? Is my livelihood going to disappear? How is this going to affect the economics of Southeast Massachusetts? And so I actually ended up shifting my research career and adding all of this component on sort of public-facing, societal-facing problems, and trying to work with economists and other folks to really understand the answers to the questions that people really wanted to know the answer to. And so all the way back, going back to this communications workshop, made me shift the entire focus of my research career. And in fact, when I got a call from, you know, one of the professors here in environmental sciences, you want to come to UVA? It was like, oh, that might be really cool because I can work with colleagues not just in oceanography, but in the natural sciences, in economics, in policy, and really move forward some of this work that's looking at not just basic science, and not even just identifying problems, but working on solutions. And so that's what's brought me here today. Now, I do want to, in case anybody's worried, I'm still working on helium isotopes. I'm still working with my graduate thesis advisor, who I've known now for close to 40 years, and we just had a paper come out a couple weeks ago looking at helium isotopes in the deep North Pacific. So if you're interested in that, come contact me, we'll chat. So thanks.
That was UVA Professor of Environmental Change, Scott Doney. Next up, we have the Dean of the School of Engineering, Jennifer West.
So, I grew up in a very happy family in Southern California. Both of my parents were public school teachers. So my dad taught high school history, and my mom taught fourth grade. And I will mention, in addition, essentially every other person I'm related to is also a public school teacher, right? So we were a very education-focused family, which brings great blessings, right? Our house, in addition to just doing the homework, it was a place where all sorts of extra supplemental projects were always happening. You could rarely see our dining room table for all the books and supplies all over it. And, my mom in particular, was willing to really go all in to make sure that the things that excited my sister and I, we had all sorts of extra exposures and really every opportunity. So my love as a child was math, as you can probably guess from being Dean of Engineering. And so my mom, I know, would actually stay up nights learning the math concepts ahead of me so that the next day she could teach them to me. And actually, I remember there was a point where she really struggled with understanding negative numbers, and yet she was all in with me. And so, moving on into high school, that's where I really was introduced into science, right? And science became my second passion. And I will say I had an AP chemistry teacher who both taught me a real love of chemistry, but also really gave me a lot of faith in myself and my abilities. So the other thing about our house, aside from education, was animals. Okay, we lived in a little bit of a zoo. We had dogs and cats, of course, but we also had rabbits, guinea pigs, chickens, parakeets, ponies, goats. I think I've hit them all now, but we had kind of one of everything. So come along kind of getting to the end of high school and thinking about what should I do with my life. And if you can think back, or for the students here, try and imagine this abomination. We did not have the internet back then, right? So one's exposure to possibilities was mostly the things around you, right? So I knew a lot of teachers, so that was one career path. Then you kind of knew doctors and lawyers, and I loved animals and science, so veterinary medicine seemed like the career path for me. So I was going to go become a veterinarian. Now, clearly, since I'm here, I am not a veterinarian. Okay, so college applications are happening. My dad, being a high school teacher, knew a little bit about college applications. Again, there's no internet. College applications, it was not just pushing another box on the Common App website, okay? It was this ordeal. And so my father and I were having a little bit of a tussle about how many colleges one should apply to. Okay, so I'd filled out a number of applications, and I was really focused on programs where I could go become a veterinarian. And as we were kind of arguing about applying to colleges, he convinced me you really have to do one more application. And so I grabbed the application that happened to be on the top of the pile of the mail that day and went ahead and applied there. Didn't really read about the school, didn't really have any interest, but filled in the application to get my dad off my back. So the school was MIT. I'm sure their alumni office would be thrilled to hear the care with which one chose to apply there. So acceptances start coming in. I got into MIT. I really didn't care. I was not going to MIT. What got me excited, I got into a program at Cornell where you could do your BS and your DVM degree integrated all at once. So I was going to the agriculture school at Cornell. That was my destiny. I was so excited. So my parents decided that it would be a really good thing if I went ahead and went on a visit to see Cornell before they actually paid the deposit for this. And so, a trip from California back to Ithaca, New York was a big financial stretch for them. So they bought one ticket and I went by myself. And this was actually my first trip. So, I'm going off by myself to do this. And there's a huge snowstorm. And I get stranded in Boston. And the little plane to Ithaca can't take off, and I'm stranded there. And again, pre-internet, pre-cell phones, even pre-ATM machines, if you can think of that. And so I'm in Logan Airport, 17 years old, panicking about what to do. So I go to the payphone and put in my coins, and I call home, explain what's going on. Like, my parents are trying to figure out. We have a series of phone calls back and forth. So my mom managed to call the admissions office at MIT and say, hey, my daughter happens to be in Boston. Could she come by for a visit? And fortunately, this woman in the admissions office was extraordinarily helpful and found a student who would let me sleep in a little cot on the floor in her room while I was there, which was good because I didn't have a credit card. I had a few traveler's checks. Like, it was not clear how I was going to survive on my own without a place to sleep. So very, very thankful just to have a place to sleep. Still not interested in MIT, right? I'm just getting this for the free night to sleep. So the next morning, I go on the tour that the nice lady from admissions had set up because, I took the free room, kind of needed to go on the tour. And so when you enter into MIT, you enter into what they call the infinite corridor. So you go in, and it literally is a corridor so long you cannot see the other end of it. And as you're going along, there were things along this corridor that were mind-blowing. There was a mainframe computer, which back then was like a really amazing thing. There was an electron microscope. There were these research labs and all sorts of amazing things. So I'm getting excited, find the tour group, and we go on. One of the things MIT does on tours is they take you to visit research labs. I didn't ever know that such a thing even existed, didn't know that there was any career path that looked like this. And so the first one we visited was a guy named Doc Edgerton, who was very famous for strobe photography to capture very fast motions. So there's like a picture of a bullet going through an apple that he's famous for. On the tour group, they let us drop drops of milk and take pictures of it. You would see these amazing patterns of not just one drop, but all these micro droplets coming off of it. And it started having me think about like different ways of seeing the world. And then 2 labs later, we visited the lab of chemical engineering professor Robert Langer, who was doing work on ways to design implants where you could have release of insulin in response to glucose demand so that diabetic patients wouldn't have to inject themselves. And I was really fascinated by this work. And so the grad student who was having to do the little presentation to the tour group, I kept asking questions and questions. The tour group was finally like, we need to go. And so this guy, Tony, was really nice, and he said, why don't you come back by after the tour's over, and we can talk some more, and we'll show you some stuff. So tour ends, and I go back, and about 8 other graduate students all go in, show me their stuff. They let me look at cells on a microscope, which at that point was just amazing to me, just all of these things that were so eye-opening. And so at the end of the day, I was walking back to the dorm room where I'm sleeping on the floor, walking along the Charles River, watching the sunset, and trying to figure out, what am I doing? This seems like the place I belong, but this isn't what my plan was, right? So I'm thinking it through. By the time I get back to the dorm, I've decided, like, this is where I belong. And so I dial the phone and make a collect call back to California, and I asked my mom to cancel the trip to Ithaca, that I just wanted to stay in Boston for the rest of the couple days, and that I wanted to send in the deposit to MIT. So one snowstorm changed the entire direction of my life, and I couldn't be happier that it did. So thank you.
We hope you've enjoyed those 2 stories, and we've got one more by the Dean of the School of Data Science, my good friend, Phil Bourne.
I started at the tender age of 61. I decided it was time for a change. So I left the sunny tenure of San Diego to take up a new post as the first Chief Data Officer of the National Institutes of Health. I don't think any of us really knew what a Chief Data Officer was supposed to do at the time, including my boss at the time, Francis Collins, who was director of the NIH. But I went there anyway, and it was hard on my family. But I just really felt that even though I really enjoyed my research, it was all about multi-scale modeling of biological systems using computational methods, and I love teaching students, and I love forming companies and doing all these things, I really felt there was more to be done. And so I don't know if it was altruistic or whatever it was, but I felt I could actually try and give back in a different way. So I decided to do this. And I traveled across country on my motorcycle, 2,500 miles in the polar vortex of 2014 to do this. Everybody said I was mad. My family said I was mad. But when I got there, it turns out that Francis Collins also rode a motorcycle. So when he would introduce me, he would say, "Here's Phil Bourne. He came across the country during the polar vortex of 2014. He only saw one other motorcycle on the way, and 4 of the 8 days that he was riding, the temperature didn't go above 0. Oh, and by the way, he knows a little about data as well. And so that's how I started off. And so I started doing this, and I realized immediately that it was quite different than what I expected. I was given like yellow pages of acronyms when I arrived. Of course, I didn't read it or even look at it. And then I'm in my first budget meeting, and they're going, well, we need to do these R01s for the NCI using OTA, and XXX is worried that this won't fly, and then POTUS will get involved. And I'm like, oh my God, what's all this about? And I thought, well, I know some of this. I know NCI is National Cancer Institute. I know what an R01 grant is. I don't know who XXX is. And POTUS, isn't that some kind of scientific society? And I went back and I went to Google, oh my gosh, you know. So it was really exciting from that point of view. But then I realized that what I was part of was this amazing operation. I'd actually read somewhere that a supertanker takes like 10 miles to turn around. It's just so big. And that's kind of what the NIH was like. So when I asked Francis, I said, well, I've got a vague idea what my job is, but tell me a little more detail. He said, your job is to take the 27 institutes and centers of NIH, $36 billion a year budgets, now 46, and we're using data and methods as a catalyst, is to actually change how we do biomedical research so we improve healthcare. I said, well, what am I going to do next week? But what I realized is there was this amazing food chain. So, for example, a couple of examples around the food chain. So, as a professor, and certainly as a graduate student in the system, you're at the end of this food chain, and you're eaten. If you're a graduate student, you're eaten by your professor. Professors are eaten by program officers and reviewers. And as you go up the chain, it gets a little more controllable. So, where does the food come from, and how does it work? And we basically would sit down and have all these kinds of meetings around designing what we were going to do to foster this kind of food chain. So as an example, once I said, you know what would be really good? Let's get together with gamers. Gamers are really interesting folks. They do lots of kind of visualization work, lots of kind of network traversal, all things that have relevance to biomedical research. So I organized this meeting, and a whole bunch of these folks showed up, including the fellow who wrote Candy Crush. We had an absolutely invigorating time together. So I go wandering into Francis's office saying, look at this brand new exciting program. He looked at it, he said, Phil, we can't do this. Read this op-ed. And he gave me an op-ed piece from the New York Times that had been written by a senator, whose name I won't mention, that basically said the NIH should not be playing games, it should be curing disease. So, okay, all right, we'll just rename it so it's not so obvious what it is we're actually doing. And so we moved it forward, and we worked on that. So, you know, that was just one example of things that we were doing. And it was just a really exciting time. And I came to realize in that period, I was frustrated by the speed at which things moved, but at the same time, we did some interesting things. We organized a whole new data model for how biomedical data should be organized. We actually got preprints, which are sort of pre-publication versions of papers, to be accepted by the NIH, which really accelerates the whole discovery process. And so all of that happened while we were playing around with all of this. So I'm really proud of the whole group of us who were involved in that. So that was, but I was also completely taken by a group of people who are really good scientists, who essentially have given themselves over to support the work of other scientists. And I think, we owe them a huge debt for what they do for us as practicing scientists and also for society. So it was just, from that point of view, it was a really rewarding time. The experiences I had there really helped, and I'm so glad I was able to bring them here to UVA. So thank you very much.
That was a story by Dean of the School of Data Science, Phil Bourne. We hope you enjoyed these stories, and we encourage you to support UVA STEM stars Sara Maloni and Sara Kucenas by listening and subscribing to Story Collider. There's a link to their feed in our show notes below. Many thanks to Misha Gajewski and the whole Story Collider team for this collaboration. And I'm Ken Ono, STEM advisor to the Provost, and the Marvin Rosenblum Professor of Mathematics. You've been listening to Who's in STEM?
Who's in STEM is a production of WTJU 91.1 FM and the Office of the Provost at the University of Virginia. Who's in STEM is produced by Catherine Kosseboom, Ria Verma, Mary Gardner-McGee, and Catherine Hansen. Our music is composed and performed by Robert Schneider and John Ferguson of Apples in Stereo. Listen and subscribe to Who's in STEM on Apple Podcasts, Spotify, or wherever you get your podcasts. We'll be back soon with another conversation about scientific and technological innovation at the university.